Every day, millions of people use applications for shopping, banking, streaming, and communication. But have you ever wondered how these applications handle millions of users without going down? What happens when traffic suddenly increases? What happens when a server or application fails? How do companies deploy new features without causing downtime? The answer involves a technology called Kubernetes. Before understanding Kubernetes, we need to understand containers. Traditionally, applications deployed heavily on server environment. If the environment changed, applications could behave differently. Hence, the containers solved this problem. A container packages the application code, libraries, and dependencies together, allowing the applications to run consistently across different environments like dev, production, and staging. Why containers created a new problem? Containers made application deployment easier. But when companies started running hundreds or thousands of containers, a new challenge appeared. How do we manage all these containers? Here the real problems should be start. Imagine a production environment with thousands of containers. If one container crashes, someone has to restart it. If traffic increases, someone has to create more containers. If a new version needs to be released, someone has to carefully deploy it. Doing everything manually is slow and also risky and almost impossible to scale. Here, the Kubernetes gives the solution for us. To solve these challenges, Kubernetes was introduced. Kubernetes is an open source container orchestration platform. In simple words, Kubernetes is the system that automatically manages containers. It helps with deployment, scaling, recovery, and managing the applications. Kubernetes does not create containers. One important thing to understand is Kubernetes does not create containers. Containers are created using container runtimes. Kubernetes manages and controls these containers. So here Kubernetes architecture we need to go through it once. A Kubernetes environment is called a cluster. A Kubernetes cluster has two main pods. One is control plane and another one is worker nodes. The control plane is the brain of the Kubernetes. It makes decisions and manages the entire cluster. The API server is a communication center. All requests go through the API server. The scheduler describes where applications should run. The control manager continuously checks whether the actual state matches the desired state or not. etcd stores the configuration and state information of the cluster. What the worker nodes do? Worker nodes are machines where applications actually run. Kubelet communicates with the control plane and ensures containers are running correctly or not. Applications run inside the pods and pods contain the containers. One of the most powerful concepts in Kubernetes is the desired state. You tell Kubernetes what you want. For example, you want 3 copies of applications running. If one pod fails and only 2 pods are running, Kubernetes automatically creates another pod to maintain the desired state. We need to go the real production example now. Now let's understand Kubernetes with a real production scenario. Imagine we are using an e-commerce application. When a customer opens the website and searches for a product, the request first comes from the user. But in real production environment, we don't directly send every request to the one server. The request first reaches to the load balancer. The load balancer distributes incoming traffic across multiple application instances. Inside Kubernetes, a service provides stable network access to our pods. Pods can be created and destroyed frequently, so their IP addresses can change. The service gives a fixed way to access these pods. During normal traffic, these pods might be enough to handle the user requests. Now imagine a festival sale or a special event. Suddenly thousands of users start accessing the application. Can these 3 pods handle this traffic? May not be. So Kubernetes can automatically increase the number of pods based on demand. Instead of an engineer manually creating new servers, Kubernetes helps auto scaling. Now imagine one pod suddenly crashes. because of application issue. Kubernetes detects that the desired number of pods is not available and create a replacement automatically. This is why Kubernetes is important in modern production environment. It helps teams improve reliability, handle traffic changes and recover from failures automatically. Kubernetes is not just a tool for running containers. It is a platform that helps companies build reliable, scalable, and highly available applications. In the next video, we will create our first Kubernetes deployment and understand the pods, deployments, services, and YAML files practically.